In this lesson, we're going to use the discriminant to determine the nature of the roots for a quadratic equation. So the first thing we want to understand is, what does it mean, the nature of the roots? So when we're looking at the nature of the roots, we're actually looking for two specific things. We're looking for the number of solutions, or the number of roots, and the type of roots. So there's two different things to find, the number and the type. So this chart here kind of breaks it down for us. So in this first example, we have one real root, one real solution, or one real root. And that occurs when the vertex is on the x-axis. In the second example, we have two real solutions, or two real roots. And there they are. It's where the graph crosses the x-axis in two places. In the next two examples, the nature of the roots is that there are two imaginary solutions. So what's happening is these graphs actually do not cross the x-axis at all. So before, you maybe learned that in Algebra 1 as being called that there are no real solutions, which is correct. But now in Algebra 2, we want to be specific and say that there's actually two imaginary solutions. So the discriminant is the formula d equals b squared minus 4ac. And this is the formula that we're going to use to determine the number and the types of roots for a given quadratic equation. Now this comes from a quadratic equation in standard form. So let's review real quick what standard form is. Standard form is when an equation is in the form y equals ax squared plus bx plus c. And the a and the b and the c are the coefficients for each of those terms. So let's look at these three examples here. Let's go ahead and calculate b squared minus 4ac for each of these examples. So the first thing I want to do is identify what are the a, the b, and the c for each equation. So for this first one, a is 1. There's no number out there, so it's actually a 1. B is negative 8. And C is positive 15. So now we're going to go ahead and plug those numbers into the formula. D equals b squared, so it's negative 8 squared, minus 4 times a, which is 1, and then times c, which is 15. Now, if you're going to type this into your calculator, make sure that you use parentheses all the way through, because the negative 8 has to be squared. It has to be negative 8 times negative 8. So you have to be smart enough to recognize that when I square that, negative 8 times negative 8, that is positive 64. So if I'm doing this without typing the whole thing in, I have to recognize that that is going to be positive 64. And then if I multiply negative 4 times 1 times 15, 4, 20, that's 60, negative 60. And then I go ahead and do the subtraction, which is 4. So D equals 4. So now that I know that D equals 4, I can take a look and see that this particular number is less than 0. 4 is greater than 0. 4 is greater than 0. So that's telling me that the discriminant is greater than 0. If the discriminant is greater than 0, then I know that there are going to be two real roots for this particular quadratic equation. I don't know what they are. I just know that there are going to be two real roots. So the graph would be something similar to this one up here, where it would cross in two places. Okay, let's look at the second example. In the second example, let's see, we have a equals 1, b equals negative 8, and c equals 16. So again, let's go ahead and plug this into our formula. D equals, again, we have negative 8 squared minus 4 times 1 times 16. So we go ahead and simplify this. Negative 8 times negative 8 is positive 64. And then I have the minus in there, and I have 4 times 1 times 16 is also 64. And 64 minus 64 equals 0. So D equals 0. So in this particular case, 0 is actually equal to 0. The discriminant equals 0. So when the discriminant actually equals 0, then I know that there is exactly one real root. And what that means, if I go back up here, is that the vertex is on the x-axis. I don't know where it is exactly, but I know it's going to be on the x-axis. Okay, and then let's look at the third example. So A is 1, B again is negative 8, and C is 20. So we're going to go ahead and plug those into our formula. D equals negative 8 squared minus 4 times 1 times 20. So we go ahead and simplify this. Negative 8 squared is 64. Negative 4 times 1 times 20 is negative 80. I do the subtraction, and D equals negative 16. So negative 16 is less than 0. It's a negative number. So since it's less than 0, that means I have two imaginary roots. Again, I don't know what those roots are. I just know there are two imaginary roots, so I can get an idea that this graph is going to look like one of these two graphs that have two imaginary roots. Now, I know a little bit more, actually, because in this particular quadratic, the A value is 1, so that means it has to open up. It's concave up. So that means it's going to look more like the left-hand graph here, where the entire quadratic parabola is above the x-axis, versus this other one. This would have a negative A value. This would have a positive A value, and this would have a negative A value. Okay, so that's how we use the discriminant to describe the nature of the root. So let's look at a couple other examples, just practice these a little bit more. So let's go ahead and calculate the discriminant to describe the nature of the roots for these bottom two. So we're going to go ahead and identify our A and our B and our C. Well, all of a sudden I recognize here that this equation is not in standard form. So the first thing I actually have to do is rewrite it and change it around. And so I'm going to move the 15x over. So I have 4x squared. I don't know that I have enough room here. Let me put this below. 4x squared. I'm going to subtract, so minus 15x plus 3 equals 0. The standard form has to equal 0 in order to be able to calculate the discriminant. Equation must equal 0. And then it must be in descending order as well. And so I notice that because I put the 15, the negative 15 in the middle, now my equation's in descending order. So now I can see that A is 4, B is negative 15, and C is 3. Now we're going to go ahead and do our calculation with the formula. So D equals B squared, so negative 15 squared, minus 4 times A, which is 4, times C, which is 3. So let's simplify this. 15 squared is going to be a positive 225 minus, and I'm going to do 16 times 3. 4 times 4 times 3 is 448. And then subtract those numbers, and I get 177. D equals 177. 177 is greater than 0. So that tells me, excuse me, that tells me that I know that since D is greater than 0, that there has to be 2 real roots. Therefore, 2 real roots. That's the nature of the roots. Again, we need to have this in order with this equal to 0. So I'm going to move the 4 over. Negative 7x squared plus 3x minus 4 equals 0. So A is negative 7, B is positive 3, and C is negative 4. So now let's plug this into our formula. D equals 3 squared minus 4 times A, which is negative 7, times C, which is negative 4. Now we're going to simplify this. Again, you can type this entire thing into your calculator and get the final answer. I'm going to just go by steps. So negative 4 times negative 7 times negative 4 is negative 112. I'm going to go ahead and subtract those, and I get D equals negative 102. Is that right? 9 minus 112, excuse me, that's 103. Okay, so now that I have 103, and it's negative 103, I know that that number is less than 0. It's a number that is less than 0. So since it's less than 0, I go up here and look at my chart. That means that there have to be 2 imaginary roots. So therefore, the nature of the roots is that there are 2 imaginary roots. And that concludes our lesson.